Hi, thank you so much for reviewing my final project. My name is Victoria. This is my submission as my final project for the Foundations in Machine Learning course. It's been a really great class. I've learned a great deal. I'm looking forward to continue on my machine learning journey. Just as a reminder, the project boundaries and goal was to develop a machine learning model to solve the problem and predict the electrical energy output for a combined cycle power plant. We were asked to determine what type of machine learning approach is needed, determine the features and the different algorithms, and look at validation strategies, and evaluate the performance of the final model using the defined output metric, which is the prediction of the electrical energy output. So the business need for this project is the prediction of a numeric target variable, specifically the electrical energy output of the combined turbine. As such, I chose a parametric model, and specifically for the first model, I wanted to run a simple linear regression. So these were the input variables, features, or X variables as they call them: temperature, ambient pressure, humidity, vacuum. And our Y values or target labels were the net hourly electrical energy output. We were given a very rich data set of about 10,000 observations, which is nice and often not the case in real life, where you have to struggle to clean your data, etc. First thing I did was split the data into training data and then a test and validation data set. So I use about 80% for training and 20% for the test validation set. And I ran a linear regression. So R2 here shows how well this data fits the regression model. And you can see that we're almost at 93%. And our mean squared error is really our cost function. This is what we'd like to bring down. That's 20.773. So here's the actual model parameters. So here you can see the coefficients, you can see the intercept, and you can see the coefficients for temperature, vacuum, pressure, etc. So this is how we're going to calculate our model. Before I walk through that, I just want to say really quickly from a feature perspective is that I ran the linear regression against a different variety of the features. So what I did was I took out one feature at a time to see what the impact would be to the R square or to our prediction capabilities. And it became very clear that temperature is the most significant feature or input variable. When I removed vacuum or ambient pressure, the impact accuracy is negative, but it only reduced the predicted target value slightly. Removing the temperature brings this accuracy way down to about 80% from where it was. So it's obviously a very significant input variable to our output. So then I wanted to run the model against the test data. So essentially what that involves in Excel is creating a manual calculation wherein you're going to look at each of these coefficients. So the coefficient value of -1.978 for temperature, you're going to take that value and multiply it by the actual temperature value, and then you're going to add that to the value for vacuum, and then you're going to multiply that, and you're going to do that across the data set. So when I ran this, I calculated then again. So this is my predicted score. Okay, so you can see on the first row 453.771, where the actual is 458. So those are this is going to result in my residuals, and from here I can also calculate the mean squared error. On the far right there, what you see is me subtracting the actual from the predicted, and then adding the exponent, so adding the y hat. What I found is when I ran the mean squared error on the test data, that my mean squared error was only slightly lower or worse, I should say. Mean squared error was slightly higher on the test data, so it didn't do too badly on data I had never seen. My mean squared error on the original data, on the training data, was 20.945, and then it fell to 20.773. I also chose to run a ridge regression and also a lasso regression because I wanted to see how one of the benefits of ridge and lasso, effectively ridge regression will force the coefficient for irrelevant features down slightly. Lasso is actually a feature selection tool and will force those coefficients of irrelevant variables to be 0. But each of them is an interesting way to look at, the sort of supervised learning algorithms to see if maybe each of these would perform better than than linear regression. As you can see, one of the nice features of this Excel that I ran was it will actually show you the variable that's most important or most influential. And as you can see, AT or temperature here is significantly more influential than the other input variables. And finally, what I found is that in order to predict electrical energy for the combined cycle power plant, Lasso or linear are going to be your best bets, providing the lowest error or cost, and provide the highest level of accuracy. So the R-squared for each of them ended up at about 93%, and the mean squared error was at 20%. Thank you for watching. I hope you enjoyed the project.